working solution to this problem, which you have a differential equation that describes the temperature profile of a rod that connects two walls. Remember that on the left you have the rod matching the temperature of the wall on the left, 40 degrees, x equals 0. On the right you have 200 degrees, x equals 10. This equation involves heat transfer through the rod and with the ambient temperature. And we worked on this script, which works. Subsequently, so actually, it was based on this formulation of the matrix equation. In particular, what I have over or under the cursor is our first treatment, which treated T0 and Tn or T5 as known quantities and used a step delta x of 2. The MATLAB script is more general than that. It works for arbitrary step size. We confirm that it agrees for the step size of 2. And then we talked about how to formulate a different way. So this matrix does not treat T0 and Tn as known quantities, but instead just uses the equation T0 equals 40 and T5 equals 200. So those are equations, rather trivial equations, but equations nonetheless. And if we use them as equations, notice that every other row between the first and the last actually follows the same pattern. So you have this -1, 2.04, which is actually, I believe, C2, and then -1. So the advantage of doing it this way, just trying to be ignorant about T0 and T5, even though we actually know them, is that it simplifies the pattern of the matrix. Some people prefer to formulate these problems this way. It's a bigger matrix, but who cares? MATLAB can do the work for us. So what I'm going to do is modify this script for the alternative formulation. So I'm just going to copy everything that defines M and B. In fact, I'll even copy the T series. And what I'm going to do is I'm actually just going to make an alternative formulation. I'm not going to attempt to replot anything. I'm actually just going to say T series 2 is going to be M2/B2. We don't have to augment it with T0 and Tn because they're already built into the problem. And before I make my modifications, wherever I see B, I'm going to change it to B2. Wherever I see M, I'm going to change it to M2. And we're just going to recalculate all the temperatures using this alternative formulation for the matrix. So the I values still apply, except I can actually go from I equals 1 to n minus 1, so I can actually expand the matrix. And remember that we've got to figure out the correspondence between the index in the problem and the row of the matrix. So when the index is 1, this is actually row 2. So I plus 1 gives us row 2. And I like to think in terms of the diagonal. So I'm going to say the diagonal is I plus 2. That is our C2. So now I've got to go 1 earlier and 1 later. Sorry, I said I plus 2. I meant I plus 1. Okay, so now this should work for filling in the matrix rows 2 through n minus 1. And I'm actually not going to worry about the index at the beginning or the end. I'm just going to say M2 of 1 comma 1 is equal to 1. And then I'm going to say B2 of 1 comma 1 is going to be T0. That's 40 degrees. Over here, I'm going to say M2 end, end. So that should be nn. Oh, why not? Let's just call it nn. We know what it is anyway. Again, that's just going to be 1, and b2n comma 1 is just going to be tn. So let's display our matrix M and M2 and B2, and now here all we really care about is whether T series 2 is the same as T series 1. So if this ends up just being a list of 0 and the two lengths are compatible, then we don't really need to replot anything because that just confirms that our answer is the same. So now let's calculate. I'm going to undock this. And we can tile it with the script. Okay, so let's run this. Oh, you know what? I should have, looks like we have made a mistake. So that should be a list of zeros that it outputs, so it clearly is not. But I'm going to go back to a step size of 2. So n would be 5, just to make everything the right size. And let's see what, so that's a 1. Oh, look, this is wrong. So the last row should have zeros and then a 1 at the end. So something is wrong with M2. Let's take a look. Okay, so we're going to go, oh, I think I know what I did wrong. The dimensions of M2 should have been defined differently. I'm surprised that didn't give us an error. So it actually should be n plus 1 by n plus 1s because you have t0 through tn. And so in fact, I think I was a little overconfident here. So I goes to n minus 1. So that looks okay, but this should actually be n plus 1 comma n plus 1. And this should be n plus 1 comma 1. So let's give that a shot. Okay, I think we have succeeded. So this matrix looks right. It has the right form. B2 is the right form, and notice this is 10 to the minus 13 times these quantities. So that is effectively 0. So I think what it tells us, let me take this semicolon off so that we can see it, and let's show T-series as well. And in fact, if you look at T-series and T-series 2, they match. And let's not display the matrix, and let's increase the number of steps. I don't remember how many we did. Let's do 50. Okay, so again, 10 to the minus 12. Let's just examine the actual temperatures. Let's look at, say, the first 3, 40, 42.54, 45, 40, 42.54, and 45. Okay, so I think we are done.